Hi, everyone.
Your microphone will go.
I know that I am the one between you and having a nice evening, so I will try to make it quick. And hopefully we can have our slides up. Cool. Thank you, everyone, for your time. So my name is Ahmed Menshawi. I am the VP of AI Engineering at MasterCard. I'm based out of UK. And my team job is really building the end-to-end pipelines around the machine learning systems. So if you come from a data science background, you understand that there is a notebook-style kind of demos or ideas where you are trying to find out if AI is really the right tool or the right technology to be used for solving your problem, or even if you can meet the business expectation from solving this problem using AI. And this is like the phase of lab demos, the phase of proof of concept. But once you have the right understanding and the right business value proven, you need to move this notebook-style proof of concept into an actual production system. And this is where my team comes into the picture. So this is the AI engineering team, so it's like a mix between software engineering and data science, and the overlap between the two. So we will see in a bit, the importance of having the right AI engineering team within your company, and we'll see some of the research as well we have done to show the complexities of having generative AI models in production compared to doing a lab demo. So as I said, we'll be covering how AI transitioned from excellence in structured data into the transformation we see now in so many domains because of generative AI. And we will also talk about the intelligence augmentation. There's a lot of hype around AI taking over and the doomsday. So we'll see some nice articles talking about intelligence augmentation and how AI or generative AI as a technology or a tool is really augmenting our day-to-day productivity. And finally, we will share with you some of the research we have done as part of my team and showing the different challenges and technical debt that you need to navigate and address if you are moving LLMs from the lab demo to production and actually getting the right ROI as part of this. So AI has been there for like decades, and I think in the last 2 decades, AI have been doing really well in labeling structured data. So you give it an image, it will be able to detect the object, and it will do so with very good accuracy. The reality is a little bit different. So Gartner estimated that more than 80% of enterprises' data is unstructured. So imagine, in MasterCard or any other company, you have the logs, you have manuals, you have documentation. So most of the data that we have as an enterprise is really unstructured. So this is like more than 80%. And 71% of them, or more than 71% of them, really struggle in managing and securing this kind of data. So is generative AI or agentic AI is a hype? And I think this is really the right answer for this question. I don't think it is, given the space that they are operating in, that we have so much unstructured data. Before generative AI, it was really almost impossible to really leverage this kind of data and build AI systems using it. Right now, you can attach it as an external memory to your LLM and have it contextualize responses and detect the patterns that you wouldn't be able to see before. And we will see some of the applications why we have used this kind of unstructured data and attaching this data in some of the MasterCard applications we have and how it boosted our accuracy in one of the models. And intelligence augmentation, as I said, this is really a very nice article from Nature. It says, stop talking about tomorrow's AI doomsday when AI poses risks today. And it really details out that, the whole conversation about the hype and the speculations about AI taking over is not really well justified. And the kind of algorithms that we have right now is not the type of algorithms that will take us to AGI. Like AGI might happen, but you cannot really tell in how many, in how many years. But the type of algorithms that we have right now is not really the ones that will take us to AGI. And I think, most of you already might, have this understanding that if you are asking a ChatGPT or any GPT assistant, if you are asking it a question and it starts to do something wrong in the middle, the error starts to amplify. So let's say you are asking it, a question about writing a piece of code about, solving some sorting problem. And at the middle, if it did like very little mistake, maybe, for changing the type of the variable from, from float to string, you will find out that this small error amplifies to a bigger problem at the end of the answer. And this is inherent in how the foundation algorithm itself works, in the transformer algorithm, that, the autoregressive nature of the algorithm itself. The next answer is dependent on the context or the previous tokens that it has generated. So if something is wrong, this wrong answer will keep amplifying the situation until the answer is really divergent from what you are looking for. So again, there is a lot of risks that AI poses today, and we need to be solving for these kind of risks and not worrying much about the doomsday and how it's taken over our jobs. And I think, this is one of the, I think one of the best quotes from the past is like almost 200 years old from Ada Lovelace. And she is known as the world's first computer programmer. And she said in her analytical engine report, and analytical engine back then is nothing but machine learning or AI as we call it today. But she said, like, AI cannot really originate anything by itself. So it cannot really, originate anything or have this kind of nonsense PhD level kind of GPT assistance. It is only doing what we order it to do or perform what we order it to do. And if you think about it, it is so right even today in all the AI applications and even the GPT assistants that we have access to. So yeah, like it's a 200 years old or like almost 170 years old code, but still holds today as we see it. And there is a nice new paradigm by LeCun from, the chief scientist from Meta. He talks about why the current algorithms that we have right now is not really the one taking us to AGI, and he's proposing a different approach or a different paradigm for AGI, which his team is working on. He did this talk in MIT and Stanford, so many universities. I think you will find it really insightful. Okay, so language models. So a lot of folks have this misconception that language models were invented by OpenAI, and I hope you don't have the same misconception. So language model and the whole idea of using the context and predicting the next token is so intuitive idea that it's almost 30 years old or 35 years old. So I try to date it back to the early paper I can find, and this is like a 1991 paper that talks about using your previous context or previous words to predict the next token. But what was really missing from this approach is the whole idea of user interface. So the whole idea that you will be able to interact with the GPT assistant model as we communicate with each other today. And it turned out that this kind of interface data is really rare on the internet. Like no one can collect it unless you have the money for hiring thousands of people to really generate answers, questions and answers, and be able to rank the answers to a certain question as how good they are compared to the question. And this is what GPT Assistant is all about, and this is what a ChatGPT is all about. So a lot of people misunderstood what a ChatGPT is all about. ChatGPT is all about fixing the interface in language models, right? So they managed to hire a lot of people, a lot of contractors, and to be able to rank the answers, to be able to generate this kind of answers and questions and answers, and do the reinforcement learning and use it to have this kind of intuitive interface that we have seen today. And as you can tell, like it's really accelerating innovations everywhere, and the Mastercard is no different. So this is a press release from my team that happened back in 2024, where we used the generative AI to boost our fraud detection accuracy in some edge cases by 300%. So this tells you how transformative this technology or this tool to so many domains and so many sectors if it was used the right way. So coming to the last part of my talk today, which I think is really important if you are thinking about taking these models into production, right? So we have few essentials of few constructs for building a generative AI application. So the first one is having access to a variety of foundation models, right? And the second one, you need to have a right environment for contextualizing or customizing this kind of LLMs. So you have the open book approach, which is, or we should talk about the closed book approach first. So the closed book approach is using the LLM as it is, right? So you have the LLM, you are just sending your prompt or your query and waiting for the answers. This is like the closed book. The model is already trained, all the parameters are already logged in, it's a closed book scenario. But you have the open book approach where the closed book itself has so many problems, right? It hallucinates, there is no attribution, you can't really tell why the LLM model is generating what it is generating. And in so many areas of high-risk AI systems, you need to explain to the end users why the AI score is coming the way it is, right? So you need to have the right explainability in place. So attribution is not there in the closed book scenario. And also stallness, like it goes out of date. And that's why you have GPT-4 and GPT-3 before that. So they keep updating it with new, with new documents, with new corpus. So the open book approach, which is the whole idea of attaching an external memory to your generator. You have LLM, but you have an external memory that contains your domain-specific data. And that's why you will be able to contextualize the output based on your domain-specific data. And there is a paper around this one which talks about how augmentation reduces hallucination in conversation, kind of rhymes, but like they showed how it really reduces the hallucination of the system, and also you can do model editing. Like if you have an application and someone decided to opt out of using your tool, you can easily remove their data from the external memory without retraining or fine-tuning your model from scratch, which is an expensive process, right? So you need an environment to be able to contextualize or customize the LLM model with your domain-specific data. But also you need to have an easy-to-use tool to build and deploy applications. Not only about attaching your data and making sure that you have the right answers coming out, but also you need to have the right guardrails. And most of the companies out there is certain access controls where if you have access to system A, you don't have access to system B. And we need to maintain the same access controls in the answers coming out of a GPT assistant, right? Like it cannot formulate answers based on a system B that you don't have access to. It needs to maintain the same access control levels that you have within your company. And finally, you need to have the scalable ML infrastructure to really make it happen. So I try to color code this based on the number of challenges that you would have in each step. And I think access to a variety of foundation models, I think thanks to Llama and Meta and some other companies, we have it in Hugging Face, and like you can easily get foundation models. It's kind of tricky to find the right one, but I think the good recipe of choosing the right foundation model is all about making sure that there is a bit of overlap between the data you have used for training the model and your domain of interest. And if there is a bit of overlap, I think it will be more likely to have the terminology and the tokens that it can represent your domain in the answers. And environment to contextualize the LLMs, I think this is challenging, but not as much. Because most of the companies really have an environments for building AI or machine learning systems. All they need to do is adding more compute, more accelerators, like GPUs, to be able to accommodate for these large language models. But I think the most challenging one is really having easy-to-use tool to build and deploy the models. And this is a very niche sort of domain by itself. Like most of the AI models we have been using before wasn't really, more than a few hundred megabytes, like 1 gigabyte maybe. But like talking about trillion parameters and billion parameters model is nothing that we have dealt with before. So most of the tools you see out there, like LangChain, LangGraph, AutoGen, most of them is really new. It has been like few years old tools. So you need to have the right choice of tools that can really help you make this happen. And also the whole idea that it's a language generation sort of solutions. So there is no deterministic way of building an evaluation or building guardrails around it. So some people can play the words and use this kind of trick to trick the LLM model itself to answer what they want to answer. And finally, you need to have a scalable infrastructure. Again, this is different from the traditional AI model because now you need to have more compute, more accelerators, really to be able to accommodate for the end users you have. And there was like a very nice graph from OpenAI where they showed that the training compute is really more than the inference compute. But at some point of time, when the end user base started to increase, the inference compute now is way more than the training compute. So you need to really accommodate for this kind of infrastructure. So this is from our papers that we published in ACM, and it shows that LLM or the code for doing the LLM model itself, the transformer model, is really small fraction of what goes into building an end-to-end AI application. It's precisely less than 3% of what goes into building the application itself. And the black box, the LLM box, is like the data science box. So this is where people are doing, data science, changing, doing some tweaks in the transformer model to change it to be, a better LLM. But all the other boxes around it is really the AI engineering world that I'm part of. So you have, domain-specific data collection, and you have the evaluation and hallucination metrics. You need to make sure that you are guardrailing your system against all of these hallucination and making sure that there is a right evaluation for your system. Also, you need to do a lot of low-level optimizations for the system. For example, if you are using LLMs, you can't really use them in real-time systems unless you do the right modifications. And it can go as low-level as doing kernel optimizations itself. Like you can go as low-level as updating the kernel code or the C++ code that NVIDIA offers to you to make sure that it gives you the response in a low latency or high throughput and comply with your use case. So yeah, I think this is very similar to the one paper we have seen from NEPS. Like NEPS had a very similar paper, but it was mainly for traditional machine learning. And they have shown as well that the machine learning code is at the core of building any AI application, but it only accounts for 5% of what goes into the model itself. And even, this was like one of the anonymous reviewers for our paper. He said, like, if we have so many challenges in adopting LLMs and building generative AI solutions, why the heck do we need even to worry about them and like build these kind of solutions? But as I said, like they are transformative. They are making impacts in most of the domains. So it's a challenge situation to bring them from a POC or a lab demo into a real AI solution. There is so many tools coming out every day that can help you really make it happen, but it is not as easy as it used to be compared to traditional machine learning. And this is some of the books from my team as well. Feel free to check it out. And I think we have time for questions. Thank you.
Do we have any questions? Just wait.
Thanks, folks.
The microphone. Wait, we have one question.
We have one? Cool.
Do you have any suggestions on how to minimize technical debt?
Yeah, so I think like technical debt is a lot, right? So let's say if you choose one, let's say the latency. So latency is one of the technical debts when you are trying to meet the business constraints. So like business constraints would have, let's say I need a response generated within few seconds or few milliseconds, right? And I think the way to address this one is really to have the right skill set, because this is different from the traditional machine learning, right? Traditional machine learning, you have small algorithms, you have more control over the latency of how the model generates the answer. But now you need to have the right skill set for going into the low-level code, the C++ code, and making the right modifications and using the right tools for making it happen. So I think the answer is really having a very specialized skill set that can do the update into the C++ code itself and make it happen. It's very different, as I said, from the traditional AI world that we used to have. And for the safeguards and making sure that we comply with privacy and like all of the high-risk regulations that we have out there, I think it's all about spending more time evaluating the system than building it, and having the right evaluation and the right SMEs for really testing your model. Right? It is not really, I think evaluating a generative AI solution is more expensive than building it. If you really care about having privacy and making sure that there is no bias in your system, I think evaluation, you need to understand, is more expensive than building the model itself. So I think if we have this right understanding and we do the right investment in hiring folks and SME folks to test the model, output is really what it takes to make sure that the model is to some extent usable for end users. It's not be like 100% perfect, but I think it will be a usable sort of model that can have less bias in its outputs. Cheers.
Okay, we have another question. I will come back.
All right, thanks for the talk, Ahmed. Could we maybe go back to the slide with the technical depth where we have the LLM in the middle?
Yeah.
So one thing I see with a lot of my customers kind of getting started in this area and maybe being limited in internal knowledge or budget that has been secured for these projects. Which of these areas do you consider good areas to really start prioritizing when we start looking at some things are probably must-haves, some things maybe nice-to-haves,
yeah.
Some things are very difficult, some things maybe a bit more accessible. So can you share your opinion on that?
Yeah, absolutely. I think it's really subjective and it depends on the business itself. So for example, if you talk about real-time systems, right, and back to the technical debt question, if you have certain business constraints that I need to have the answer within few milliseconds, or otherwise I'm losing my end user, right? I need to generate some score based on the Gen AI model, and I'm using this score to augment another AI system. And if I didn't meet the business constraint, I'm not getting any value out of it. So in this case, having the right modifications and having the right quantization and pruning in place is very important compared to anything else, right? And safeguards is important when you have like a customer-facing. So generative AI doesn't need to be customer-facing, right? It doesn't need to be like a chatbot interface that people are asking questions. It could be something else. It could be like a Gen AI model driving features from some other unstructured data that you have and then using it for another model. But if it's a customer-facing model and you really care about having fairness in the outputs and making sure that no one feels excluded, then you need to have the right safeguards in place. So it depends on the business and what really matters for them. But I think, yeah, and resources as well is key, right? So most of the companies don't really have the open resources that like Microsoft or NVIDIA or Google has. They have very limited number of GPUs that they need to utilize these number of GPUs for the solution. And you need to work around it. Like there's no other way of asking for more investment, right? And in this case, you need to have the right trade-off between complexity and utility. Right? You need to tell business, right, I can get you, somehow 90% accurate model, but you need to do like, let's say, few million investment in getting more GPUs or more accelerators. Or I can get you like an 85% accurate model with the resources that I have now. So this is like the trade-off between complexity and utility. And in these cases, you need to care more about model pruning, about quantization, about memory management, and how you make sure that what you have is really can get the system to work with a certain acceptable accuracy.
So that really feels like almost an engineering / architecture perspective here, not letting us get too distracted by the LLM stuff. Is that a good way to view it?
Absolutely, yeah. But I think it needs to be influenced by business as well. And like the resources, the investment, what really matters more, the consumption layer of your solution. Is it a customer facing? Is it like something internal that, in some sort of an air-sealed environment where no one have access to? So if it went wrong, if it's biased, no one cares much. But yeah, like engineering is key as well, definitely.
Okay, great, thanks.
Cheers.
Let's click on the question.
Yes, I'd like to ask maybe a naive question, but since we saw today the automation process that can be solved with AI, how possible is it to use AI, generative AI, to solve this kind of problems? Or maybe to create a new one in order to solve this kind of I don't know if you tried. I don't know. This is the first.
It's a very good one. No, it's a very good question, actually. So reverse engineering the situation. So yeah, to be honest, we do it. Like if some people use like GitHub code assistance and so many other tools to be able to update the C++ code and like go into the kernel level details. Like I mean, but most of it is niche, right? What makes code assistant or GitHub code assistant really good is whatever you are thinking about or whatever you are trying to code is somewhere on GitHub in so many repos, right? That's why it is trying to consolidate all of these repos and get you, the best out of them. But in certain niche areas, and I have tried, ChatGPT myself in certain niche areas. So let's say you have a new paper coming out, and and this is like a first to see algorithm basically, and they have a notebook on GitHub, and like literally I see ChatGPT. You can try it out yourself. Is mimicking the notebook line by line. Like it is literally changing the variable names, and like the function names are the same, but like changing the variable names, a bit of the explanation, but it's literally mimicking the whole notebook, line by line. So it tells you it's overfitting the notebooks that's available there because you don't have so many instances of it. So back to your question, I think in certain areas where it's niche, I think it's going to be really hard. You can get it to like maybe rise the initial starting point and then you can keep reiterating. But again, there is a caveat of making sure that it writes it in a few seconds and then you spend 2 months trying to solve the issues between the lines, right? Make it more modularized and decoupled is that you can detect the issues in certain components and be able to fix it. But you are right. In some areas of this, I think we are doing it. It could be used to use it. Exactly. To solve LLM problems, use LLMs to solve it. Yeah, absolutely.
Ahmed, thank you very much for this session.
Thank you. Thanks for.
And actually, thank you all for being here today. This is the end of the day 1 of this summit. Thanks, of course, OT Academy and the sponsors that host us here. And looking forward to seeing you tomorrow morning. Thank you very much.